So how do we get around escaping references? Well, the first point to note is that references can only escape if we have methods that are returning a pointer to an object. In this instance, the getCustomers method is returning a pointer to the map. So what we're going to have to do is look for ways to avoid returning pointers to existing objects. Let's view this class in Eclipse so that we can try out different techniques for avoiding the escaping reference. There's a project, again in the starting workspace for this chapter, called Escaping References, so load up this project in Eclipse. I'll do that now. I've copied it to my workspace. So here's the project, and we've got the customer class, the customer records class, and the main class. And these all contain the code that we saw on screen a few moments ago. Actually, let's start with the customer class. So the customer class, as you can see, has a constructor where we can set the name, and there is also a getName method. There's no set name in here just at the moment. And our customer records class, that's over here, well, that is exactly the same as we saw on screen. So we've got a private map, but the getCustomers method is returning the reference to that private map. So that's where our escaping reference is going to be. Just to prove the point, if I run this first of all from the main method to check it's working, so we should see two customers when we iterate through them, one called John, one called Simon. Let's just run that. Okay, that's worked. And to prove the point, what I should be able to do here is say records.getCustomers. That's going to return the reference to my map, and I should be able to call .clear on that object, and that will delete those customers, proving that our reference has escaped and that we've been able to mutate it. And if I do that, when I run the loop here, we should get nothing printed out. So let's just do that. And indeed, we've got nothing printed out to the console. I'm going to comment out that line. In this chapter, I'm going to be writing quite a bit of code that then I'll comment out. I'm doing that just so it's in the final workspace for you to look at. Obviously, we wouldn't normally write code and comment it out a lot, but hopefully you understand I'm doing that just so that you've got this in the final workspace if you want to look at it at some point in the future. So I want to look at some different approaches to how we get around this problem. Now, one approach, and we don't see this too often in Java, is that we could make customer records an iterable class and then provide an iterator to the objects that we want to be able to iterate through. I'm going to have a go at doing this so that you can see what we mean. So we're going to say that customer records is going to implement the iterable interface, and it's going to be iterating objects of type customer. Now, having typed that in, we can see we've got a red squiggly line here, which will be telling me that if we're going to implement the iterable interface, we've got to provide an implementation for the iterator method. And so I'm going to get the IDE to create the method stub for me. And that's done that down here. So we need to put something in here. We need to return an object of type iterator. Well, we can do that from our map. So what we should be able to return is, we'll start with our map, that's called records. I want to get the values from the map, and then that is going to be a list of the customers. And as you can see, we can just get the iterator directly from there. So I should be able to just return that object. So having done that, what that allows me to do, I'll just save this file, is back in my main class, as an alternative way of iterating through these, again, I'm going to just comment this out for now. What we should be able to do instead is say for our object of type customer, but this time we just need to call records, because records is an iterable class of customers. We've implemented that, and we can then just print out the next object. I think I'll just copy the print line down here, and that should work. So let's just check first of all that that has worked, that we've not broken anything. Good, I've got my two customers printed out here. And now let's think about, have we fixed the problem? Have we removed the escaping reference? Well, first of all, I'll point out that I've not actually removed the getCustomers method. I think the point here is that we no longer need this, and therefore the only way to actually access the objects is through this iterator. So is there any damage we can do with the iterator? Can we change, can we mutate somehow the objects? Well, unfortunately, we can. It's not a perfect solution, but it is a bit difficult. What we need to do to break this is to start by getting a reference to our iterator object. So that will be records.iterator, and I'm going to store that as a local variable, and it's a variable of type iterator of customers, and I'll just call it it. And then, I just need to import iterator. Let's do that. Okay, so now I can call it.next. That's going to move the iterator so that it's pointing at a customer object. Having done that, I can call it.remove, and that will remove an object from the collection. And to prove that that has caused us some damage, if we rerun this loop, I'll copy that loop and put it after we've called remove. And then let's run this code again. What we should see is that the first time we loop through, we get both Simon and John. The second time, we have managed to remove Simon. So we have still mutated our list of customers. Now, I would describe this as a not perfect solution. We clearly do have some form of escaping reference here. We've been able to mutate some state, but we've made it quite difficult to do. So this could be a good enough solution for you. It's not a perfect solution. We will look at some better ones. But before we do that, let's just talk about what's the performance impact of this solution. Well, it turns out this is a 0 performance impact solution. And what I mean by that is that the change we've made to the code by making this class implement the iterable interface and providing the reference to the iterator rather than a reference to the map has no impact on the performance of the application in any way. Now I'm going to leave you to test this if you wish to. We will be looking at how we test performance of different options for our code later in the course, but although this isn't the best solution from the coding point of view, it will not have any impact on performance. It's going to be exactly the same performance as the previous version. So if this is a good enough solution for you and performance is critical, then this is certainly something I would consider.